parametric equations. So one way to define functions is to define both elements of the ordered pair x and y in terms of another variable t called a parameter. So we're going to start with this example of graphing a parametric equation. So number one says a robot moves along a factory floor that has coordinates drawn on it to guide the robot. The x and y coordinates of the robot's position are functions of time t. The time at which we start observing the robot is t equals 0. Complete the table and connect the points with a smooth curve. So if t equals 0, our x-coordinate is defined as 6 minus t squared. Our y-coordinate is defined as 2t minus 4, and then we'll plug in the t value, do the math, and then put x and y together as our coordinate pair that we will plot on our grid. So if I plug in 0 for t, 0 squared is 0, 6 minus 0 gives us 6. If I plug in 0 here, 2 times 0 is 0, take away 4 gives us negative 4. So our first coordinate pair will be 6, negative 4. And we will plot that on our grid. But I do recommend for these you fill in the whole table first, just so you know what you need to count by to make things fit on your grid. So if we plug in 1, 1 squared is 1, 6 minus 1 is 5, 2 times 1 is 2, take away 4 gives us negative 2. If I plug in 2, 2 squared is 4, 6 minus 4 is 2, 2 times 2, 4, minus 4 is 0, and so we get 2, 0. If I plug in 3, 3 squared is 9, 6 minus 9 is negative 3, 2 times 3 is 6, take away 4 gives us 2, and so we get negative 3, 2. Okay, so I just need to make sure I can get to 6 on the x-axis. 1, 2, 3, 4, 5, 6, so that's fine. Our biggest y value is 2 or negative 4, so we are fine to count by ones. So now I'll start plotting. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So there's 6, negative 4, 5's at negative 2, 2, 0, and negative 3 is up at positive 2. So there are points, and we'll connect them with a nice smooth curve. So that would be the path of that robot. All right, so the next thing we're going to talk about is how to eliminate the parameter. So solve one of the parametric equations for t, then substitute that resulting expression into the other parametric equation and simplify. So maybe we don't want two equations in terms of t, we just want to put them together and have one more traditional x, y type of equation. So that's called eliminating the parameter. So again, I'm going to take one of these and solve for t. So we typically take the x equation and solve for t. So I'm going to subtract the 2 to the other side. So we have x minus 2 equals 2t. And then I'm going to divide by 2. So if I divide this all by 2, I'll get 1/2 x minus 1 equals t, which I can now plug in what t equals in place of t in my y equation. So y would equal 3, and instead of adding t, I'll add on what I know t equals, which is 1/2 x minus 1. And so if I combine like terms, I see this is a linear equation, 1/2 x plus 2. So we will now go ahead and fill in our table and graph it like we did in the previous example. But this is our equation after we have eliminated the parameter. But let's go ahead and use these to fill this in. So if we're supposed to go from 0 to 2, remember they're giving us a domain interval there. So that's 0, 1, and 2. So if I plug 0 in for t, 2 times 0 is 0, plus 2 gives me 2. If I plug into the other one, 3 plus 0 is 3, so my first coordinate pair is 2, 3. If I plug in 1, 2 times 1 is 2, plus 2 is 4. If I plug 1 into the y equation, 3 plus 1 gives us 4. So we have the coordinate pair 4, 4. If I plug in 2, 2 times 2, 4, plus 2, 6. 3 plus 2, 5. So we've got 6, 5. All right, so we can go ahead and plot those. So 2, 3. 4, 4, and then 6 is up at 5, and so we can see Here's our path. For the original, but let's take a look at if we have eliminated the parameter where these will translate to. So because they said to use from t equals 0 to t equals 2, so if t equals 0, that corresponds to an x value of 2. And then if t equals 2, that corresponds to an x value of 6. So the new domain interval would be from 2 to 6 that we have graphed that function on. All right, so again, when they talk about eliminating the parameter, we're going to take one of the equations. We typically choose the x one. We're going to solve it for t, so that we can figure out what t equals. Then we're going to plug it into the other one and simplify to come out with a more traditional xy type of equation that no longer has that parameter of t in there. I'm sorry. All right, so on to the next one. So problem 3, x equals t minus 2, y equals t squared minus 3t. So let's do our table first this time. So we're supposed to use t values from -1 to 4. Okay, so if we plug -1 in for t, -1 take away 2 more is -3. -1 squared would be 1, but then -3 times -1 is +3. So 1 plus 3 gives us 4. So our first coordinate pair is -3, 4. Then if we plug in 0 minus 2 gives us -2. 0 squared is 0, minus 0 would give us 0. So we have -2, 0. If we plug in 1, 1 minus 2, -1. 1 squared is 1, minus 3 gives us -2. 2 minus 2 is 0. 2 squared is 4, minus 6 would be -2. 3 minus 2 is 1. 9 minus 9 is 0. So again, remember, I'm just taking this number, plugging it in here to get my x, plugging in here and here to get my y. So if I plug in 4, 4 minus 2 gives me 2. 4 squared is 16. 3 times 4 is 12, so 16 minus 12 gives me 4. So there are all of my coordinate pairs. So I'm going to go ahead and plot them. So -3 is up at 4, -2, 0, -1, -2, 0, -2, 1, 0, and 2, 4. So if we connect those with our nice smooth curve, there we go. So we moved along this pathway here is how we were moving. All right, now let's eliminate the parameter. So let's take x equals t minus 2, solve it for t. So we'll move the 2 over and see that t equals x plus 2. So if we plug that into our other equation, I got to plug it in every place there's a t. And then I got to do proper algebra. So x plus 2 quantity squared. Remember, that's a binomial squared. So you got to do x plus 2 times x plus 2 and get x squared plus 4x for those outsides and insides plus 4. Distribute here and get -3x minus 6. So if we combine like terms, y equals x squared plus x minus 2. So we've got a quadratic, which is what we see in our graph as well. The new domain interval, we can see it goes from -3 to 2. All right, another example here using some trig functions this time. So we're supposed to go from 0 to 2 pi. So we'll count by pi halves. So we'll do 0, pi over 2, 2 pi over 2 would be pi, and then 3 pi over 2, and then 4 pi over 2 is the 2 pi we're supposed to end up with. All right, so if I plug in 0, the cosine of 0 is 1, times 2 gives us 2. If I plug it in here, the sine of 0 is 0, times 2 would be 0. Pi halves, so cosine of pi halves is 0, times 2, 0. Sine of pi halves is 1, times 2 is 2. If I plug in pi, cosine of pi is -1, times 2 is -2. Sine of pi is 0, times 2, 0. Gotta be able to evaluate those trig functions quickly and easily. Plug in 3 pi over 2, so cosine of 3 pi over 2 is 0, times 2 is 0. The sine of 3 pi over 2 is -1, times the 2 gives us -2. 2 pi, so the cosine of 2 pi would be 1, times 2 is 2. Sine of 2 pi would be 0. So let's go ahead and plot our points. So we start at 2, 0, then we go to 0, 2, then we go -2, 0, then we go 0, -2, and then we're back to 2, 0. So we're following this circular pathway. I forgot that on Notability I can have it help me draw a nice circle. Let's see if I can do it. There we go. And so we're headed this direction. Oops. We started here, was t equals 0, and then we went up and around counterclockwise. Okay, so to eliminate the parameter, again, I've got to have a little bit of a different strategy this time. So I can't like divide away a cosine and things. So instead, and especially knowing that we have the circle here, we are going to square both sides of our equation. Because we know for a circle it should be x squared plus y squared. So if x equals 2 cosine of t, we're going to go ahead and square both sides to get us that x squared that we know we'll need for a circular equation. And also, we know that sine squared plus cosine squared equals 1 from our Pythagorean identity. So that's going to be helpful as well. So if y equals 2 times the sine of t, if we square both sides, we see y squared equals 4 sine squared of t. And so if we would add these two together, so x squared plus y squared would equal 4 cosine squared t plus sine squared of t. We can factor out that 4 from the right-hand side since they both have it. And then we will have cosine squared t plus sine squared t, which is our Pythagorean identity. We know that equals 1. So what we really have is x squared plus y squared equals 4, the equation of our circle. And so our new domain is going from -2 to 2. Only uses those x values. So if we see we're getting a circle, we know equation of a circle is the x quantity squared plus the y quantity squared equals our radius squared. So we knew we needed to get x squared and y squared. And if we want to cancel out sine and cosine, Pythagorean identity is a good way to do that. So we need like a cosine squared plus sine squared or sine squared plus cosine squared. So that's the trick we use. Square both sides, add them together. Take out any GCF so that you just have this, which equals 1, and then you've got your equation. All right, one more here. So number 5, we want to eliminate the parameter. Same idea as the last one. As soon as we see this cosine and sine in there, we're going to take and get the cosine and sine expression by itself. So I do need to subtract the 4 to the other side for the x, and then I'm going to add the 1 to the other side for the y, so that the cosine expression and sine expression are all by themselves. Then I'll square both sides. I won't actually multiply out the left. I'll just keep it x minus 4 quantity squared. On the right side, 4 squared is 16, and then cosine squared of t. Same thing for y. So we'll have y plus 1 quantity squared equals 16 times sine squared of t. And so now if I add these together, x minus 4 quantity squared plus y plus 1 quantity squared has to equal the sum of the other sides of the equations. So 16 cosine squared t plus 16 sine squared of t. And then since they both have a 16, we will factor that out as the greatest common factor. Leaving us with just cosine squared of t plus sine squared of t, which is the Pythagorean identity. We know that equals 1. So what we really have is the equation of our circle, x minus 4 quantity squared plus y plus 1 quantity squared equals 16. Now remember, that would be a circle with a center at 4, -1, because it's always opposite signs, so positive 4, -1, and the radius would be 4, the square root of this constant. Just to review our last little lesson on circles. All right, but so eliminating the parameter, we're getting rid of the t, and so we either take what they give us, take like the x, solve it for t, substitute it in, and simplify. Or if we see we have these trig functions in there and we're going to end up with a circle, our trick is to get the cosine and sine expressions by themselves and then square both sides. Then take the two equations and add them together. So we'll add the left sides together on one side equals, add the right side of the equations together on the other side of equals. Take out a GCF, use the Pythagorean identity to realize this is just 1. So 16 times 1 just gives us 16. And there's our equation without the parameter.